Most questions on the IGCSE involving arithmetic series do throw up nice numbers, so there's an easy methodology to work through. Unfortunately, this one doesn't, and it can be a little bit confusing, but it really shouldn't be. The starting point with all of these is just write down everything that you know from the question. You're given the formula for the sum of a arithmetic series. So that is S of n equals n over 2 square bracket 2a plus in bracket n minus 1d. You're given that one in the exam, but you must learn and remember the nth term, normally written as u of n, which is a plus n minus 1d. It's similar to the inside here, but it's only got 1a rather than 2. That's one way of remembering it. So these are the two formulas we're going to use. Let's write the information from the question using these. We know that for the sum of a certain number of terms, capital N, so S of capital N, I have 292 is what my sum equals. Replace little n with capital N, so I've got n over 2 square bracket 2a, I don't know what the first term is, plus in brackets capital N minus 1, close bracket multiplied by d, that's the common difference, and I don't know what that is either. Now I know that the second term, so u2, second term is 8.5, so 8.5 equals a plus n, which is 2, so 2 minus 1 multiplied by d. So just simplifying it a little bit, I have 8.5 equals a plus d. I also have my fifth term, so u of 5. So 13, which is my fifth term, equals a plus bracket 5 minus 1, that's my n minus 1 multiplied by d, or simplifying it, just get 13 equals a plus 4d. Now a typical question like this, we have two simultaneous equations. This one is equation number 1, this one is equation number 2. So if we solve the two simultaneous equations, we will have a value for a and for d. We'll have our first term and our common difference. These ones simplify quite nicely. I can do equation 2, subtract equation 1. 13 take away 8.5 is going to be 4.5. A minus 8 cancel. 4d take away d is 3d. And this is working out quite nice. Therefore, d is equal to 4.5 divided by 3, which is 1.5. So that's my common difference. I can substitute that into any of the equations I've labelled. So I'm going to put it into equation number 1. So it's going to go into equation 1. So I have 8.5 equals a plus 1.5, so a is equal to 8.5 minus 1.5, which is equal to 7. So there's my first term. Now I can take both of these values and put them into my expression here, my a and my d, and then I have one expression here with one unknown, which is n. So let's put that over on the right hand side. I'm going to change to blue. So what do I have now? I have 292 equals to capital N, which is the number I'm trying to find, over 2 multiplied by 2 times a was 2 times 7 plus brackets capital N minus 1 close bracket 1.5. So far so good. Now let's tidy this up a little bit. I'm going to multiply through by 2 because that gets rid of my n over 2 fraction. So I'm going to have 584 equals n. And in my bracket now, 2 times 7 is 14, so I can simplify that. Plus I have 1.5n minus 1.5. This is starting to look rather horrible. 584 is equal to n multiplied by 14, take away 1.5 is going to be 12.5. So it's 12.5 plus 1.5n. You may be able to see where this is going. So 584 is equal to 12.5n, so I'm expanding my bracket, plus 1.5n squared. I certainly don't like the look of that. Now it's a quadratic, so let's make it equal to 0 by subtracting the 584 from both sides. So 0 equals, now let's bring, at the same time, let's bring the squared term to the front, just so it looks like a quadratic in the sort of form we normally see. So 1.5n squared plus 12.5n minus 584. That is horrible. Now at this point you are probably going to jump straight for the quadratic formula, and I wouldn't blame you, but it's got decimals, and decimals don't go nicely into the quadratic formula, so I think it's probably worth just multiplying through by 2 the left-hand side would then obviously still be 0. We would get 3n squared, and that would be plus 25n, and that would be minus, what on earth is that? That's going to be 1168. So at this point, yeah, jump to the quadratic formula. You get given that in the exam. I'm not going to go through that here. That's a separate video in a way. And then you will come up with your solution where you get n equals 16 or minus 73 over 3. Clearly n has to be a whole number, and it has to be positive because n is the number of terms in an arithmetic series. So it starts with 1 and 2 and 3 and so on. So it cannot be this one. So the answer must be 16. The brave ones of you, if you don't like the quadratic formula, you could actually factorize that. It does factorize. It factorizes. I was going to say nicely, but it's not nice at all. It goes to 3n plus 73 and n minus 16. But to be honest, if you're able to do that in the exam, you really shouldn't be doing the GCSE, in my opinion. You should be doing A-level. That's horrible. So yeah, use the quadratic formula, get the two answers, check you can do that, and then obviously you need to pick the answer that is a positive whole integer, and then the question is done.